Hello, this is Mr. Collier, and today we are doing line of best fit and linear regression using the HP prime calculator. Okay, so first we're going to do line of best fit, which you sort of do by hand, but we're also going to use technology to find the mean point which the line of best fit needs to go through. So first we have like data, predicted height of daisies and actual height of daisies. So we want to see if there's a relationship between those. Let's call the predicted height x, the actual height y, and I'm going to type all this data into my calculator. I'll go to, this is two variable statistics, so I'll go to apps, two variable statistics, and you type in all the data into C1 and C2, make sure they're all correct. And to get the mean point, I believe we just click on stats here. Now stats will give us correlation coefficient, which shows that there's a strong positive relationship here. If I click on x, I'll get the x statistics, so I'll have the mean of the x values here, which is 6.03, and if I click on this y button, I get the mean of the y values, which is 6.09. Okay, so that means the mean point, which the line of best fit must go through, is 6.03, 6.09. Okay, so we can also click on plot to see what this, actually I have to escape. I click on plot to see what this kind of relationship looks like, and you can zoom in a bit on that. So that's what the graph looks like, and so here I've got the graph, the scatter plot, and the mean point is plotted. There's 6.03 comma 6.09, and you see it's right in the middle because it's the average of the x values and the average of the y values is right in the middle. Then when you draw your line of best fit, it should follow the trend of the points, which looks like it's going up this way. Try to get about the same number of points above and below the line. Okay. So we're going to get the equation of this line now, and we know this line goes to this point, 6.03, 6.09, and we're just going to find another point on this line that it goes through, so we find the equation of the line. I like to pick one further away so it's more accurate, and maybe we'll pick this point right here, which is 2 comma 3, and we'll find the equation of the line. We can get the slope first, so we can do 6.09 minus 3 over 6.03 minus 2, which is 3.09 over 4.03. Okay, let's calculate that on our calculator. 3.09 divided by 4.03 is 0.767. It's approximately 0.767. Okay, so that's our slope. I'm going to do point slope form and find the rest of the equation. So this is point slope form. So we're going to have y equals 0.767x and distribute this guy over here. 2 times 0.767, and then I'm going to add 3, and I'm just going to do this on my calculator to figure out what the y-intercept of the function is going to be now. So I can take negative 2 times our answer before, you can go up and click on it, plus 3, which is 1.47. So it's y equals 0.767x plus 1.47. Okay, so that's the line of best fit by hand. Your calculator can do an even more accurate version called a linear regression equation. And in order to get the linear regression equation on the HP prime, I believe we need to click on up here at symbol. Click on, let me escape this for a second. Actually, let me go to apps, statistics again. Click on symbol, and there's the equation right there. Okay. So that is what you need to make sure C1 and C2 are in here, but it spits out this equation 0.747 0.747x, and the y-intercept is 1.59. Okay, so this one should be a little bit more accurate than the one you did by hand.